Let's now investigate the quantum of the decay of the B quark. We will investigate the electric charge, the spin, and the weak charge first. Looking at the electric charge for the B quark, we'll see that the electric charge for the generic D is given by the anti-T Rishon of -1/3, and there's no contribution by the two neutral bosons. And we will see that it will be corresponding opposite quanta for the anti-B quark. Now we can look at the C quark, the product of the decay, and we'll see that we still have the -1/3 electric charge provided by the anti-T quark, though we now the T quark is changed from orange purple featured to a green purple featured anti-T quark. And we'll look, and this time there is a charge provided by the scalar boson plus 2/3 on the flavored V and 1/3 on the prime T Rishon, providing a charge of 1, which then for the whole C quark will sum to 2/3 electric charge. And then we can go on down and look at the W- boson that is emitted, and we'll see that the spin contributing particle antipar contributes 0 to the electric charge, but the anti-V flavored Rishon is -2/3, and the prime anti-T Rishon is -1/3, giving you a -1 for the boson minus, and there's no contribution for the associated neutral 0 scalar boson. And so there we have electric charge. Let's check spin. So the spin on the generic D is provided, just like the electric charge, by the anti-T Rishon, which is a spin of 1/2, and it's a right-handed particle because the spins on the anti-V's cancel. Likewise, the spins of the components of the neutral bosons also cancel. So the spin of the B quark is 1/2. And then if we look at the C quark, we'll see that the D quark now has a -1/2 spin, or it's left-handed, due to the exchange of the orange purple featured anti-T with the green purple featured anti-T. And there is no contribution to the spin by the boson plus. And in resulting this exchange here results in a boson 0 particle-antiparticle pair with the spin of 1, carrying away the spin of 1 that was originally on the B quark with the boson, the W-, with the scalar part of it contributing nothing to the spin, and this other neutral boson part contributing 0 to the spin. And of course the spin on the anti-B will be correspondingly the opposite that it was on the B quark. Last, let's take a look at the weak charge. By the standard model is predicted if we have a right-hand particle that we should have a 0 weak charge. And so we can see on this generic D that we have 1/6 plus 1/6 is 1/3 minus 1/3 is 0. And the neutral bosons contribute nothing to the weak charge here. And then we can see on the C quark, since the spin has changed to minus 1/2, or it's left-handed, and we have a left-hand generic D, we now have a weak charge, and that weak charge is minus 1/3 plus minus 1/3, which is minus 2/3 plus 1/6, which is minus 3/6, or minus 1/2, which is the correct charge according to the standard model on the generic D quark. But this boson plus changes that generic D into a C quark, and we can see here we have weak charge on the flavored V of 2/3 and on the prime T of 1/3, and altogether that would make a flavor of 1, which will convert the, not flavor, but weak charge, will convert the weak charge of minus 1/2 into plus 1/2, which is what is predicted for the C quark in the standard model. Now we can look here and we'll see that the boson 0 now contributes a weak charge of 1/2. You have minus 1 for the boson minus, which makes a weak charge of minus 1/2 on the W minus particle. And of course the weak charges on the anti-B will be correspondingly opposite to those on the B. Well, we've taken a look at the electric charge, the spin, and the weak charge.